Today, just like yesterday, we are going to talk about the method of substitution to solve a system of equations. Remember, a system of equations is just more than one equation with the same variables. So in this example, I have a system of equations because I have two equations and I see x's and y's in both the equations. With the substitution method, we always look for just a y or just an x. And it's even more helpful when I have y that is just by itself or x that is just by itself, which I see here in this first equation. So this first equation is telling me that y and x plus 1 are equal to each other. They mean the same thing. So in the second equation, instead of writing y, I'm now going to write x plus 1. Y is going to come out of the game and his sub's going to come in. In the game, y is just hanging out, so his sub is just going to hang out. And anything else in that equation, they're going to stay the same. So I have 4x plus 1 equal to 6 now. And now I have an equation where I can solve out for x. I see 4x plus x. These are like terms, and I can combine them because they're on the same side of the equal sign, and they're both x's. So now my equation looks like 5x plus 1 equal to 6. 5 and x are best friends. We're going to wait to break them up to the end. So to get rid of the plus 1, I'm going to subtract 1 from both sides. 5x now equals 5. If I divide both sides by 5, I'm getting x equals 1. I know what x is, so now I'm going to take that x value and plug it into one of my equations. Make sure you plug it in for the correct variable. It's x, so we need to plug it in for x into that equation. So now I can find y by doing y equals 1 plus 1 or y equals 2. I also could have plugged it into this first equation at this spot, and I also would have got y equal to 2. Remember, your answer to a system of equations is an x comma y point. So your answer would be 1 comma 2. Moving on to the next example. Here, I do not see an equation that has just x by itself or just y by itself. But in that first equation, I see a y that has no coefficient attached to it, no number attached to it. So I can easily solve this equation out for y by doing plus 2x plus 2x. So I have this new equation of y is equal to 3 plus 2x. Remember, I didn't change that top equation, I just made it look a little different. So now I know that y and 3 plus 2x are the same thing, they're equal. So in this equation, I'm going to take y out, and I'm going to sub in his replacement. In that top equation, y is getting multiplied by a negative 2, so his sub needs to be multiplied by a negative 2. To show that multiplication, I'm going to put parentheses around the 3 plus 2x. Now I have a number outside of parentheses, so I need to do the distributive property, the rainbow rule. And remember, anything before it or after it does not change. Now I look at my equation, I can combine some like terms. So I have negative 1x minus 6 equals 5. I'm then going to add 6 to both sides to get negative 1x equals 11. Then I'm going to divide both sides by negative 1 to get x equals negative 11. I now can take that answer of x, plug back in, and find y. So y would be equal to 3 plus 2 times a negative 11. Once again, put parentheses around that negative 11 to show multiplication. So y equals 3. 2 times a negative 11 is a negative 22. So then y equals negative 19. So your x comma y answer is negative 11 comma negative 19. In this example, we have a y equals by itself, so I don't have to get x or y by itself. It's already done for me. So in this bottom equation, I'm going to take y out and put in its replacement. Then my equation looks like x minus x plus 2 equals 3. I can then combine some like terms. X minus x, they cancel each other out. They disappear, and I'm left with 2 equals 3. Remember in our solving equations in the beginning of the year, when we have our variables disappear and we're left with a not true equation, 2 does not equal 3, our answer is no solution. What this also means is if you would graph these two lines, you would find that there's no solution. So that means that these lines are parallel. They will never intersect. The last example we're going to do, y is solved out. So I don't have to do that. So in the second equation, instead of writing y, I can write negative x plus 4. In that bottom equation, y is getting multiplied by 3, so I need to multiply its replacement by 3. I then see a number outside of parentheses, so I need to do the distributive property, that rainbow rule. And remember, once again, anything before it or after it stays exactly the same. I then look and combine my like terms. 3x minus 3x cancels each other out. I no longer have any x's, and I'm left with 12 equals 12. In this situation, my variable has disappeared, but I'm left with a true equation. If you're left with a true equation, 12 does equal 12, your answer is infinite solutions. And remember, this means if I have infinite solutions, when I graph these two equations on a graph paper, this would mean that they're intersecting in infinitely many spots, so they are exactly the same line.